Hi, Bob Rasooli with another exam question for the API 1169 certification. Today, we're looking at a challenging open book problem taken directly from 49 CFR 192, which is one of the federal regulations you will have access to during the exam. Even though it's open book, many candidates fail these questions because they involve exact numerical requirements from Subpart G and Subpart E. Let's dive into a technical scenario that will truly test your field understanding. During construction of a 16-inch carbon steel transmission line, the inspector observes that a field bend is required to change direction. The pipe contains a longitudinal seam. The contractor forms a cold field bend producing a total deflection of 9 degrees, and the longitudinal seam is positioned 45 degrees away from the neutral axis of the bend. The pipe is being installed in a Class 2 location and will operate at 48% specified minimum yield strength, or SMYS. According to 49 CFR 192 requirements for field bends, what must the inspector determine is acceptable before allowing the installation to continue? A. The bend is acceptable because any field bend under 12 degrees is allowed, and seam placement does not matter as long as the bend contour looks smooth. B. The bend is acceptable because CFR 192.313 allows up to 12.5 degrees of bend for any pipeline operating below 50% specified minimum yield strength, and the seam may be placed in any orientation. C. The bend is not acceptable because CFR 192.313 requires the longitudinal seam to be placed as near as practicable to the neutral axis on cold field bends, unless certain exceptions are met, which this pipe does not qualify for. D. The bend is not acceptable because CFR 192.313 prohibits any field bend over 3 degrees in Class 2 locations for pipe operating above 40% specified minimum yield strength, requiring the bend to be removed and replaced. Option A is incorrect because it assumes that any bend below 12 degrees is automatically acceptable and that seam placement does not matter. According to 49 CFR 192.313, a field bend must not impair the serviceability of the pipe, must have a smooth contour, and critically, the longitudinal weld seam must be placed as near as practicable to the neutral axis of the bend unless the pipe falls under one of the specific exceptions. In this scenario, the seam has been positioned 45 degrees away from the neutral axis, which does not meet the requirement. Option A ignores the seam orientation rule entirely, so it cannot be correct. Option B is incorrect because it incorrectly states that CFR 192.313 allows any pipeline operating below 50% specified minimum yield strength to have bends up to 12.5 degrees with seam placement in any orientation. That rule does not exist in CFR 192. Instead, the regulation focuses on the method of bending, the smoothness of the bend, and most importantly, the required seam alignment near the neutral axis, unless one of the allowable exceptions applies. This pipe does not meet those exceptions, and seam orientation is still mandatory. For that reason, the logic in option B does not align with the actual regulatory language. Option C is the correct answer because it accurately reflects 49 CFR 192.313A3. The regulation requires the longitudinal weld seam to be placed as near as practicable to the neutral axis of a cold field bend, unless the pipe is small enough or an internal bending mandrel is used. In this situation, the pipe is 16 inches, was bent cold, and no internal mandrel was used. That means none of the exceptions apply. Because the longitudinal seam is 45 degrees off the neutral axis, the bend violates the CFR requirement. Option C properly identifies this and states that the bend is not acceptable. Option D is incorrect because it claims CFR 192 prohibits bends over 3 degrees in Class 2 when operating above 40% specified minimum yield strength. This rule does not exist anywhere in 49 CFR 192. Field bend limitations are not determined by class location or operating stress percentage. The correct regulatory criteria involve smooth contour, absence of mechanical damage, and proper seam placement near the neutral axis. Option D invents a restriction not supported by the regulation, making it an incorrect interpretation.